Welcome back. Today we're going to talk about equations with fraction or decimal coefficients. Okay, so I just want to do a quick review on how to add, subtract, multiply, and divide fractions. So remember, when you add and subtract fractions, you actually have to get like denominators, okay? When you multiply and divide, let me actually start with multiplication and division. When you multiply and divide, it's very easy. You can actually just multiply across, right? So the product of the numerators is 35, the product of the denominators is 81, and then you can go about trying to reduce it. I'm not going to include that here for the sake of time, but if they share a common factor, you can reduce them. When you divide, you use keep, change, flip, which is you keep the first fraction, you change the operation to multiplication, and you reciprocate the second fraction. And then you just go about multiplying them. And this one's actually really easy to 3/10. Really easy to reduce. Okay, so it's very easy to do multiplication and division because you don't need like denominators. But when you have addition and subtraction, you do need like denominators. So the best thing for you to do is try to think about the lowest common denominator, which would be a number that's a multiple of both 9 and 12, but is smaller than the product of both 9 and 12. So we can think about that because they share a common factor of 3. So actually, let's think. 36 is actually the lowest common denominator here. So we can multiply this by 4 over 4 and multiply this by 3 over 3. So then we get 32 over 36 plus 33 over 36. Now, when you add them together, what you do is you keep the like denominator, but you add together the numerators. So this is going to be 55. So we have 55 over 36. And you could turn this into a mixed number if you wanted to. You could turn it into a decimal if you wanted to, but I'm not going to include that here today. Okay, the lowest common multiple of 15 and 20 is going to be 60. So I multiply this by 4 over 4 and this by 5 over 5 to get 44 over 60. Oops, that's 44 over 60. And we get 25 over 60. Let me just make this a little bit better all around here. So we have 44 over 60 minus 20 over 60. So this is going to be 16 over 60, which you can go ahead and reduce to 8 over 30. I think that's as far as you can reduce it to. So remember, when you add and subtract, you need to have common denominators, but when you multiply and divide, you do not need them. Now, we're going to talk today, which is about something that's an 8th grade skill, which is fractions or equations that have fractions as coefficients. So here we see that there's, we're trying to solve this equation, and our variable is n. We have the same variable, we have terms with n on both sides. So we're going to have to use strategies that we used yesterday to get rid of the variables on one of the sides here. But the coefficients here, as well as one of the constants, they're fractions, right? And so this is one of the 8th grade skills that we're going to have to learn to deal with. And so I'm going to go over 2 methods of solving equations that have fractions as coefficients. Okay, one of the methods is to try to get rid of the fractions. Now, you have to be careful when you're doing this because you want to consider all the fractions in the equation. So here we have a fraction with a denominator of 10, then here with a denominator of 2, and then here with a denominator of 5. Now, remember, what I do to one side, I can do anything that I want to an equation as long as I do it to both sides. So I want to strategically pick a number that I can multiply both sides by that will eliminate fractions, will eliminate all the fractions, okay? And I can see now that 10 is a multiple of 10, 2, and 5. So if I multiply both sides of the equation by 10, okay, so I'm putting both sides in fraction brackets, so that, or sorry, in parentheses. I use parentheses for both sides because I'm going to have to distribute this 10 into both the terms. So notice what I'm doing is I'm taking 10 and I'm multiplying it by both sides of the equation. This is totally fine as long as I do the same thing to both sides. Now notice, I can't just multiply 10 by one of the fractions. I have to actually do it to both sides, and each side has 2 terms. So I'm going to have to distribute this into both the terms here. So what I really have is 10 times 7/10 n plus 10 times 3 over 2, and that's equal to, and again I'm going to have to distribute it here, 10 times 3/5 n plus 10 times 2. Okay, so when I do this, I'm just going to have to go carefully. Remember, if you have a whole number and you multiply it by a fraction, let's put this over 1. So here when I'm multiplying 10 by 7/10, I just multiply the numerators. This would be 70 over 10. Another thing I could do is just reduce it before I multiply. So I have a 10 in the numerator and a 10 in the denominator, so those actually just cancel each other out to get 1s. So I have 7 times 1 is 7 divided by 1. That's just going to have a coefficient of 7. So what I'm left with, 7/10 n times 10 is just 7. Plus, okay, over here, I have 10 and I'm multiplying it by 3 over 2, but I can reduce it by doing, dividing both 10 by 2, which gets me 5, and 2 by 2, which gets me 1. So what I have here is just 5 times 3, which is 15, divided by 1. So that's just 15, okay? Here, again, I can just take this and reduce it. I have 10 over 1, divide 10 by 5, I get 2, divide 5 by 2 by 5, I get 1. Here I have 6 over 1, which is just 6, so I have 6n plus, and then this is just 10 times 2, which is 20. Now I just have an equation with, because I chose 10 to be a multiple of all the denominators here, I'm left with an equation that is a very simple equation to solve. So I can go ahead and solve these equations the way that we did for the equations yesterday. So n is equal to 5, okay? And again, I can go through and check this if I wanted to, but in the interest of time, I'm not going to do that. Okay, that's method number 1. Method number 2 is just to take the fractions and solve with the fractions, right? This is not, you know, any more difficult than the combination of solving equations and adding or subtracting fractions, which we've seen before in multiplying and dividing fractions. So we've seen operations with fractions before. We've seen solving equations before. So it's not a huge deal to actually just combine these two skills. So here are the terms with the, let me just highlight them. Here are the terms with the n in it, okay? And here are the constants. So these things are going to have to be, these things are going to have, so the yellow ones are going to, I'm going to have to eliminate part of the terms with the coefficient in it, or with the variable in it, and I'm going to have to put the constants together. So let's go ahead and start by just taking away 3/5 n on both sides. So here, what this is going to look like is, okay, this goes away. We have 7/10 n minus 3/5 n plus 3/2. And that's going to be equal to 2 because that goes away. Okay, well, 7/10 n minus 3/5 n. Well, here these two are like terms because they have the same variable, and the variables are each raised to the first power. So same variable, same power means that they are like terms. I can combine like terms by combining the coefficients. So here I want to take 7/10, let me just do this on the side, and I want to subtract 3/5. Well, in order to do that, I need to get common denominators, so let's make this into 10 here. So I have 7/10 minus 6/10, which is just 1/10. So here I combine these two to get 1/10 n plus 3 over 2 is equal to 2. Okay, now 3 over 2 and 2, these are constants, so I want to get them on the same side. So I'm going to subtract 3 over 2 is just 1.5, right? So I have 1/10 n is equal to, well, 2 minus 1.5, I just know that that's going to be a half here. Okay, so I have 1 over 10 n is equal to 1/2. Well, if we think about it, there's a quick way of doing this. 1 over 10 n is the same as if we made n into a fraction, I'd have 1 times n, which is n, and 10 times 1, which is 10. So this is the same thing as n over 10. That's equal to 1/2. But what I have here are, we have two fractions that are set equal to each other, so I have proportions. So here I can use cross products. Okay, so I know that this times this is going to be the same, is equal to 10 times 1. So 2 times n is just 2n, and that's going to be equal to 10 times 1, which is 10. And now I've gotten rid of both the fractions, and I can just solve them outright. Okay, n is equal to 5. So it takes a little bit of time to solve these equations with fractions as coefficients, but it's not a huge amount of time, and it's totally, you know, it's it's pretty understandable because you know how to both solve equations and work with fractions, so you're just combining these two skills. Notice that this step right here, another thing you could have done is if you had 1/10 n is equal to 1/2 and you don't want to make proportions, the other thing that you could do is just multiply by the reciprocal of this coefficient here. Okay, so that would be 10 over 1. That's because a number times its reciprocal is equal to 1. And so here, if you just have 1n is equal to, this would be 10 over 2. Well, 1n is just n, and 10 over 2 is 5. So that's another way of doing that. You can put them into proportions, or you can multiply by its reciprocal. Either way, you're going to get the same thing. Okay, so there's two methods of working with equations with fractions. Okay, let's deal with a more complicated word problem. All right, Javier walks from his house to the zoo at a constant rate. Okay, so this is important information that he walks at a constant rate. After walking 3/4 of a mile, he meets his brother Raul, and they continue walking at the same constant rate. So this is also important, that this constant rate is the same as this constant rate. After they arrive at the zoo, Javier has walked for half an hour, and Raul has walked for 2/10 of an hour. What is the rate in miles per hour at which the brothers walk to the zoo? Well, okay. We know that this rate right here and this rate right here are the same. So Javier walks to meet his brother, and they walk at the same rate to get to the zoo. And Javier has been walking for half an hour, whereas Raul has been only walking 3/10 of an hour after they get to the zoo. So that means that before Javier met Raul, he had already walked 3/10 of an hour, right? So this is what Javier walked in order to meet his brother, okay? So this is hours. Okay, well, in 3/10 of an hour, he went 3/4 of a mile. So distance equals rate times time. Let's remember this formula. It's very important to remember this formula. So we know that 3/4 of a mile is your distance. So he went 0.75, and he went at some rate r times the amount of time, which is 3/10. Okay, so here's the formula that we're going to have to solve for r. So let me just rewrite it here. 0.75. And you know what I like to do is I like to turn fractions. This is the multiplication symbol, and this is the decimal here. I like to turn fractions into, decimals into fractions, because it's easier for me to work with. That's one way of me dealing with this. So I'm going to write this as 3/4 is equal to r times 3/10. Okay, and then I'm going to write this as a coefficient. So another way of writing this is 3/4 is equal to 3/10r, and I'm going to try to solve for r. Now, like I said before, there's two methods of doing this. I can make proportions, okay, or I can multiply by the reciprocal. So let me just go, I can make proportions, so I can say this is 3/4 is equal to, put r over 1, this would be 3r over 10. Okay, and then I could use cross products. 3 times 10 is 30, and that's going to be equal to 12r. And then I'm going to divide by 12 here, and r is going to be equal to 2.5. So it would be 2.5, and the units that we're using is miles per hour. Okay, because it's a rate. So Javier walked 2.5 miles per 1 hour. The other way of doing this is 3/4 is equal to, let's say, we have 3/10 r. You can multiply by the reciprocal, which is 10 over 3. Okay, now remember, if you can just rearrange this, this is 3/10 times 10/3 r, because multiplication is commutative, so I can put these two numbers next to each other. And this is just going to get you that 1r, or r by itself. Okay, that's why multiplying by the reciprocal works, because you get a coefficient of 1. On the left-hand side, the 3's cancel out, and you just have 10/4. Well, 10/4 is 5/2, and that's 2.5, which is r. And that's, again, that 2.5 miles per hour. So there's a couple different ways you can do that. Now, I sort of focus more on the method than the word problem here, but make sure that you're understanding how I'm using the distances rate times time formula in order to solve for the rate. Now, this only worked because they walked at the same constant rate that Javier walked before he met Raul. That meaning that the 3/10 of an hour that he walked before he got to Raul, I can solve for that rate, and it's going to be the same rate that the brothers walked to the zoo at. Okay, otherwise we're going to have to use a more complicated system of solving to get the actual answer here. But the answer here is Raul and Javier walked 2.5 miles per hour to get to the zoo. Right, and that's the end of the lesson for today. So again, just a real quick recap. We talked about equations with rational numbers as coefficients. When you have decimals, I find the easiest thing to do is to turn them into fractions and then deal with the first part of the lesson, which is how to solve equations with fractions in it. Okay. Otherwise, you can just divide each side by a decimal. If you have a calculator, that might be a little easier, but if you don't, then turn them into fractions. It makes the operations a lot easier. All right, that's it.